Hello students, welcome to basic science class. My name is Oilami Jane Titune. Today we'll be talking about the topic titled energy. Okay, before I go ahead, I would like to remind you of our normal procedure, which is saying at the right place, free of distractions and noises, and make sure you have your notebook and your pen with you so we can have a smooth and interactive class. Okay, over to our objective today. The first thing we are going to be looking at on the objective is that at the end of this class, we must be able to define the term energy. We must be able to explain the meaning of energy. We should be able to state and describe the sources, sources of energy. And as well, we should be able to explain at the end of this class why the sun is the ultimate source, sun as the ultimate source of energy. And the next one is talking about the forms of energy. We have to know different forms of energy that we have. And last on my list is knowing about the transformation of energy, how it can be transformed from one type of energy or form of energy to the other. So starting with energy, what is energy? Energy is the ability to do work. Ability, you must be able. How can you be able? You must have the strength. That means you can't tell the person that hasn't eaten anything all day to carry a heavy load, or else you need someone to fall there. So you have to have enough energy. That's ability to do work. Without energy, you cannot do any work. So the amount of work done by a body depends on the distance through which it moves. The amount of work done, the level, the quantity, you can quantify the work done. The quantity of the work being done by a body, it depends on the distance through which the work is being done, through which it moves. Anything that can move on its own has energy. Energy is used to do work quickly over a long time. I can decide to jump from now to the next 1 hour because I have the energy. I can decide to take this class for the next 2 hours if it won't be boring to you because I have the energy. So the faster work is done, the greater the amount of energy needed to do the work. That just explains what I talked or said right now. So the faster, how fast you can do that work depends on the amount of energy you have in you, to do that work. So we move to examples. Under examples, we have a man pulling or pushing. You either pull or push. A man pulling or pushing a car can do so as a result of what? Energy. Because the man has energy, he can pull, he can push. Same thing with a woman carrying a tray of yams on her head is doing some work and using up energy. At the same time, the woman is putting load on her head, and simultaneously the woman is either standing or walking. So she's doing the work through a distance. Do you understand? So energy is used to do work quickly over a long time. The faster work is done, the greater the amount of energy needed to do the work. The rate of which work is done is called power. So when you say I have power, that means you have energy to do that work for a long period of time. Rate, when you talk about rate, you are talking of time. when you quantify your work done, your energy with your time, you are talking of power. Energy is the ability to do work. And at the same time, if you quantify the work done by the time, that's rate, okay? That will come to what we call power. Okay, so work and energy are measured in joules, okay? It's represented by capital J. That's the unit. That's the unit of work as well as energy, okay? So for the energy we obtain from food is used to perform our daily activities. Anything you do daily is because you have the energy. And how can you have energy as human being? Is because you've taken some rice or yam or bread, whichever thing you take. So the energy is always obtained from food, okay, which is used in doing or carrying out our daily activities. You can walk, you can talk, you can write. So those are part of the things we do on daily basis. Okay, the electric energy from electricity is used to run different machines and operate electrical appliances. Okay, in your house now, the electricity supplied by PHCN, you can use it to switch on your pumping machine to pump your water. You can use it to wash your clothes by using our washing machine. So you can use electricity. The electric energy in the electricity helps you to run different machines in your house. So same thing with the second one, chemical energy from petrol, okay, is used to run vehicles, generator, and whatever machine you can think of that uses petrol. Sources of energy. So we have different sources of energy, and we are going to talk about them one after the other. Sources of energy, the first one on my list is solar energy. So this is the light energy from sun, okay, and is converted into food by green plant through the process called photosynthesis. You can still remember your photosynthesis, okay? That's the process whereby green plants manufacture their food from sunlight using carbon dioxide, which is your CO2, and water in the presence of what? Oxygen, okay? So that's the process. The process whereby green plants manufacture their food is called photosynthesis, and they can only manufacture it when there is solar energy. That's the light energy from the sun. So without sun, there will be no life, certainly, because either you like it or not, you and I get our food from plants. Okay, if plants cannot synthesize their food, if they can't manufacture their food, that means we will never go hungry. But most of the things we eat are specifically plants. Okay, is either we eat vegetable, we eat beans, we eat rice. In short, virtually everything is made of plants. So you understand when I said without sun, there will be no life. Okay, the ray of the sun can be trapped into solar cell or panel, okay, wherein it gets transformed into electricity. There is a solar panel, you know, these are a lot of people, because of epileptic power supply in our country, a lot of people put solar panel on top the roof of their houses, or you can even have as small as the one you can be carrying about to charge your phone and all that. So when the rays of sun is being trapped into the panel of the solar, it can be transformed into electricity, whereby you can use it to light your entire house, you can use it to run machines, to do a lot of things. So this Second one is wind power. Wind power, as wind blows, okay, it rotates turbine blade. You know, there's this rotary engine put in dam. We have it in a dam whereby it's used in generating our electricity. Okay, when the wind blows, it rotates turbine blades, which when connected to a generator convert the blade rotation to electricity. That's one way of generating electricity. Then the third one is hydroelectric power. Okay, hydroelectric power, you know, dammed water. When you say dammed water, when you obstruct water from flowing, you place something there so that the flowing water will stop flowing. You call it dammed water. Okay, dammed water is usually used to generate power, which drives water turbine and a generator to produce electricity. Okay, that's all about hydroelectric power. That's a form of energy. Then the next one is food. You can get your energy from food too. That's one source of energy. The food eaten by an individual is burnt. You know, during respiration, your food is being broken down and it is being released. Okay, it's burnt up to release energy during respiration. The energy released in form of heat and mechanical energy is used to do work. So the next one on our list is biofuel. Okay, biofuels, these are fuel that are made from plants and animal. They include methane from wood droppings, coal, and animal waste. Biofuel are used to heat homes, for cooking, running machine, and etc. Okay, this next one is petrol. Okay, this is one of the major products of crude oil. A car uses petrol, as we all know. Any vehicle, is either the vehicle is using petrol or diesel. Okay, a car uses petrol to move about. There are some set of cars. Then the petrol supplies energy to the car, just like food supplies energy to your body. Okay, so the next one is natural gas. Natural gas. It occurs naturally together with petroleum under the ground. Okay, it is fuel which can be used to generate heat, electricity, and light. You can use natural gas to generate heat, electricity, and light. It is also used to run large engines. Okay, we now move to the subheading which says sun is the ultimate source of energy. Why do we call sun the ultimate source of energy? Because it's very, very important. It's very important. Without sun, there won't be life. Just like I explained earlier on, sun is the ultimate source of energy. Light energy from sun is converted into food by green plants through the process called photosynthesis. So how the process goes is that when sun is shining, plants uses there's this green parts in the leaf called is a green pigment, gives that leaf the green color. So specifically green plants are the ones that manufacture their food through this process called photosynthesis. So the sun energy is being trapped into the chlorophyll, and there the plant works on it and convert that light energy into chemical energy, which the green plants can always use to produce or for growth. Okay, without sun there will be no life. Note that, without sun, aside the fact that we get our food from plants, and plants needs the plant needs sun, that's light energy from the sun, for the growth to take place. At the same time, if we don't have sun, the entire earth will be cold. Nobody can survive it. So for everything we have to have, is very important. We have to have the sun. So this is the diagram showing you how the sun ray, the ray of sun, the light, is being trapped into the green plants, and from there water is being trapped by the roots from the underground. Those are the things plants use for photosynthesis: the carbon dioxide, which so many call carbon dioxide, the carbohydrates in the leaf, and the light energy from the sun. The oxygen is being given off by the plant. That's what we use. That's why most times we are being advised to plant around our houses. So the plant, during respiration of the plants, oxygen can be released, so there will be fresh air. And in the soil, we have water being trapped by the roots too. So that's how green plants generally manufacture their food. Okay, moving to forms of energy. We have different forms of energy. The first one is chemical energy. So energy contained in food substances: petrol, coal, wood, candle, kerosene, diesel, etc. are classified as what? Chemical energy. Then when you talk of electricity energy, we are talking of energy which can be detected using voltmeter. Okay, there's an instrument called voltmeter. It's used to deflect or to dictate the if there's electricity in a particular instrument or machine or whichever thing you can think of. So on that voltmeter, there's a needle like it's like a tiny needle like, where it will be deflected. If there is electricity on a material, it will deflect. So it will show you there is source of electricity there. So you dare be careful before you touch. And it can be used to run television sets. Electricity energy is the one we use in our houses, aside the fact that we use solar panel. We use the electricity supplied to us by Power Holding Company of Nigeria. So to power on our television sets, our refrigerators, microwave, and what have you. Okay, solar energy, this is energy from sun. As I said earlier on, it can be used to produce light and electricity. Sound energy, this energy is got from vibration of objects. Okay, when there is vibration, when you hit an object or there is disturbance on an object, there should be a sound. Okay, so the heat energy now, which is the next one, is the type of energy transmitted due to the difference in temperature. Okay, when you apply heat to something, you can turn cold water to hot water, or you turn raw rice to cooked one. So that's the kind of heat energy we are talking about, where you can measure the temperature. Okay, so it can be used for cooking and ironing clothes. For atomic or nuclear energy, this is produced when the nucleus of an atom is split. Okay, when you split the nucleus of an atom, you know, for every element there is a central nucleus. So nucleus can be split. That's where you see it when we are talking of atoms. When you talk of elements, it can be used in it's a form of energy you can find in all these nuclear bombs and all that. So light energy is a form of energy visible to the human eyes, just like we have it when you put on light in the house. It travels a very high speed, about 300,000 kilometers per second. So in a second, the rate at which the light travels is 300,000 300,000 kilometers. So in a straight line, except if you place something on the path, that's why you have deflection. Okay, so white light is made up of 7 colors which can be seen in rainbow. Rainbow, at times when you draw your rainbow or you see it in the sky, you notice there are 7 of them. So visible light is used for lighting in lamps, electric bulbs, and any light you can think of. So forms of energy. So this diagram is just showing you what we just talked about. So this is mechanical energy. Okay, you can see the figure how mechanical energy is being exhibited in the fan. Okay, what is it? Energy. Okay, so the energy that moves, or energy or motion, is what you call mechanical. And under mechanical, I will still get there. We have 2 types of mechanical energy. So for electrical, just like the socket or the plug you use at home, so electricity flows through this, giving you the form of electrical energy. Same thing with lights, your torch lights or your light bulb and all that. Thermal energy, when there is heat moving in a molecule. Then sound energy can be made from your instrument and the lights. So we talk about mechanical energy now. This is the energy used to do work. There are 2 types of mechanical energy. The first one is kinetic energy. When you talk of kinetic energy, you are talking of any object that is moving. Any moving object possesses anything you see moving, either you are moving or an ant is moving or any animal is moving, that thing or that object possesses what we call kinetic energy. So any object that is moving has kinetic energy. That's it. So an example, when you throw a ball, okay, the moving of the ball, that means the ball has kinetic energy. Same thing with moving car, or maybe you are walking, you possess kinetic energy. And you can calculate kinetic energy, which is Ke equals to what? 1/2 times m, which is our mass, and v square, which is our velocity. Okay, whereby K dot E is same thing as kinetic energy. So formula for kinetic energy at any point in time is this, where you have Ke, that's kinetic energy, equals to half mv squared, where your m is mass and v is velocity. That's speed by which the object is moving. That's velocity. Okay, so the second type of mechanical energy is a potential energy. Energy due to position of an object. E.g., you have a rubber band, you stretch it. When you stretch a rubber band, it tries to come back to that initial position. Same thing with a wound spring. When you try to, those ones you normally have at your doorstep, maybe when you have a net at your doorstep, you open it, there's this spring. It's pull out and pull in. So whenever it's exhibiting that kind of motion, going and coming back to initial position, is exhibiting potential energy. That's energy due to position. Okay, they all possess potential energy because they can do work as they move from and back to their position. Okay, so the formula for calculating potential energy is P equals to mgh, where P is abbreviation for potential energy, and m stands for mass of the object, g stands for acceleration due to gravity. That one is always constant. They will give you to be 10 meters per second. per second squared. Okay, they always give you as that figure. It's a constant. Some books will give you as 9.8 meter per second square. Some will give you 10 meter per second square. So height, which is h, then PE is abbreviation. So the unit of both kinetic and potential energy is joules. Transformation of energy. When we have energy being transformed from one form to the other, this is it. Chemical to light, where you have your kerosene stove, chemical energy in the kerosene, changing to light for you to cook. Candle, same thing. Gas lamp, lantern, and all that. So the second one, chemical to heat, we have examples there too. And for chemical to mechanical, we have example for vehicles, diesel engine, locomotive engine. We have chemical to electrical energy, which we can see in our lead accumulator or batteries, car batteries. We have it in electrolytic cells. And electrical to heat energy, that's what we have in our water heater. Electric energy is being converted to heat energy. Same thing in your electric iron and all that. So we have it electrical to mechanical too in electric motor, in electric fan. There's a part of the fan called electric motor. So it drives the fan. It's the one that allows the fan to work perfectly. So grinding machine, we have the electric energy being converted. That's the one you use in grinding your pepper or what have you. So electric to sound energy, we have the loudspeaker, we have the radio, we have our cassette players and all that. So for our mechanical energy to electrical energy, that means it's coming from a machine to electric. You can see that in generating plants. You can see that in dynamo. So we move to our next one, which is talking about mechanical energy to sound energy in our bells, in our turning fork, which we use in agriculture. Same thing with our light energy to chemical energy, where we have light from the sun being converted to chemical in green plants, as the case may be. So these are your class activities. You are to be supervised by your parents or parents. Okay, so apparatus needed. You need a matchbox, you need a candle, and proceed your pupil to strike a match on a matchbox. That's the first thing. The second one is that you as a pupil, you should watch what happened. Okay, watch what happens and light the candle. As soon as you strike the match, just watch what happens in between, and then you light the candle. You know, we talk about our apparatus. So you light the candle. The step 3 says pupil to put palm of hand over the candle. So you have to place your hand over the candle a bit and observe what you can feel. All observations are to be written in column. I would create when sending your assessments. Okay, so I'll have your observation and what you feel your results are. You write it for me there. So the class activities in the above slide is the typical illustration of how energy is being transformed from one form to the other. In writing the results of your observation, confirm all this. You have to confirm and write it for me. So make sure you stay safe and be happy.